Okay, these are some more notes over on section 4.3, and I just want to look at this graph and see what happens with the slope here. And here my slope is positive. Okay? But if you look at it, it's still positive, but it's getting to be less and less positive, less and less positive, less and less positive, less and less positive, and then all of a sudden if you look at the slope here, it's 0. And now it's negative, and it gets to be more and more negative, more and more negative, more and more negative, more and more negative, until I get about here. Then it starts to get, even though it's negative, it gets to be less negative, next less negative. It starts moving along the number line, if you think about it that way, to 0 again, and then back up. So let's take a look. That's a good idea to draw a number line. We can put a 0 on here, I guess. And draw this point over here. So if we look at, again, if we look at our slope is positive here, okay? It's still positive, positive. I mean, it's still positive. But look what's happening to the tip here. This is what we want to talk about. The slope is positive, but it's less and less positive. So this is 0 over here. If you think about this, is 0. The slope is getting to be, it's starting out, oh, sorry, so we're on this side. It starts out really, really positive. Okay? And it's going to be, it gets less and less and less positive until I get over here to 0. And then it goes like this until I get all the way over to here. Okay? So it's negative, and then it's going to start moving back this way. Oops, try to get it to be 0. And then it's going to be moving more and more positive. Okay? So let's again kind of see what I'm talking about here, because it might be a little confusing. If you look at the tip of this line, and this is kind of maybe, you know, if you think of this as a little car, or look at the car, as the tip moves counterclockwise, what's happening to the slope? Well, the slope is decreasing. Even though it's positive, it's not as positive. So it starts out as a real steep slope, and it goes to 0. And then it goes all the way down here till I get down to this point here. So all this time, okay, the slope is going from real steep to 0 to negative. It's moving to the left. All right? So we'd say the rate of change of the slope, actually the change of the slope is decreasing. In this whole area here, the rate of the change of the slope is decreasing. It starts out very, very, very steep, very, very positive, and then it goes to 0, and then it keeps getting more negative till all of a sudden it stops, and then it starts working its way back to 0 and going back up here. Okay? And then when the little tip of this line is not moving counterclockwise but clockwise, then it looks like the slope is increasing. Well, when we talk about decreasing and increasing, we're talking about the change of the slope. So all this time over here, the slope is decreasing. And then over here, the slope is increasing. So I hope you can see that, and I hope that makes sense, all right? Okay, so in this range over here, the slope starts out, and again, we'll look at this number line. This is real positive, so slope starts out real positive. This will kind of help you if you're trying to graph these things too, these first and second derivatives. But here, this is we're talking about the slope, and the slope's real steep. And then it goes down to 0, but then it keeps getting negative until it stops right here at this particular point, which is a very important point we'll talk about. And again, you can see the little tip of this line is moving counterclockwise. Then all of a sudden, it starts moving clockwise. The tip starts moving clockwise, and here my slope is still negative, but now it's moving back to 0, and like this, back to the positive. So when the slope is moving to the left, it's decreasing. When the slope is moving to the right, it's increasing. So the slope is decreasing here, it's increasing there. Well, if we look at our curve is what we say concave down. while the slope is decreasing, concave up when the slope is increasing. Well, when we're talking about the slope, if the slope is y prime, and we're talking about the change of slope decreasing, we would say that its derivative, the slope is, when the slope is negative, the function is decreasing. All right. So when the slope is negative, the function is decreasing. So when the slope is decreasing, its derivative is negative. So y double prime is negative. Okay. And we say when the function is increasing, the slope is positive. So if the slope is increasing, its derivative is positive. So the derivative of the slope, which is the second derivative, is greater than 0. So hopefully that kind of justifies why this works. In other words, we're talking about this change of the slope or the slope of the slope. All right? If we graph the derivative, we would see what we're talking about here. Okay? So I hope that makes sense. It's a little hard to see, but you know, I remember having to think about this when I was in college, when I was first studying this. Okay, so again, here, even though my slope is positive, it's not so positive. So starting over here, getting to be 0, and getting over here. So its change is negative. So because it's moving to the left. Okay, then as it starts to get more and more positive, it gets to 0. And going like this, and it's moving to the right, so it's increasing. So if the slope is increasing, its derivative would be positive. Just like if a function is increasing, its derivative is positive. If the slope is increasing, its derivative, which is the second derivative, is positive. And just like when a function is decreasing, its derivative is negative. So when the slope is decreasing, its derivative is negative, but the slope is already the derivative, so that's the second derivative. So hopefully that makes sense, all right? And then we're going to do some examples and give you some notes on these in just a second. But this is what we really want you to kind of think about. You know, in a way, we're talking about the slope of the slope. The slope of the slope, which is y double prime. Okay? Second derivative. Okay? So hopefully that'll make kind of some sense to you.